Welcome back to the Foundry by Forge College. I'm really thrilled to have you here for another explainer. Now, if you were with us for our last session on robust error handling and retry strategies, you learned how to make your decentralized apps resilient. Basically, you learned how not to drop the keys to your smart contracts when the network gets a bit choppy. Well, today we're actually focusing entirely on those keys themselves. We're diving into ownership transfer practices, which is an absolutely critical piece of our applied Solidity development track. You see, it's not just about giving someone special privileges, it's about how you hand those privileges off safely, transparently, and sometimes how you destroy them completely.
So, here's our map for today. We'll start with the digital crown, move on to secure transfer, check out the paper trail, visit a metaphorical volcano, do some testing of the flow, and finally, wrap up. Let's get started.
Section 1. The digital crown. Smart contract ownership basics.
Okay, let's dive into this. To really get your head around access control and Solidity, try imagining your smart contract as a literal digital kingdom. And in this kingdom, certain actions, like draining the treasury or tweaking core parameters, well, they simply can't be open to the general public, right? There needs to be a ruler. In code, this crown is represented by a canonical state variable simply called the owner. It's a specific Ethereum address that's permanently stored on the blockchain. But look, a crown just sitting on a table isn't safe. It needs a royal guard. That is exactly where the onlyOwner modifier steps in. Think of it as a bouncer that checks every incoming transaction, essentially asking, hey, are you the exact address stored in the owner variable? If the answer is yes, the gates open. If no, the transaction is immediately booted out.
Section 2. Secure transfer. Passing the privileges safely.
So, establishing an owner is literally just step 1. Practical smart contracts rarely stay under the control of a single deployer forever. You're probably going to need to hand over control to a multi-sig wallet, maybe a DAO, or just a new admin key. So you've got to pass that crown. And here is the golden, unbreakable rule of this pattern. Only the current owner can grant a new owner. If the current owner calls transfer ownership, boom, the transaction succeeds and a new address is officially crowned. But imagine a non-owner as some medieval usurper trying to sneak into the throne room. When they try to call that function, the ownable royal guard steps in and blocks the transaction with a crystal clear revert message. Ownable, caller is not the owner. The usurper gets kicked out, the contract state stays completely untouched, and your digital kingdom is perfectly safe.
Section 3. The paper trail. Auditable changes of control.
Passing the crown securely is great, but remember, in Web3, transparency is just as crucial. When power changes hands, the kingdom's scribes don't just nod quietly. No, they write it down in the permanent, historical record, so the whole realm knows about it. And this brilliantly illustrates how we handle it in our smart contracts. We create this exact paper trail using the OwnershipTransferred event. Emitting this event isn't just a nice-to-have. It's a first-class requirement to keep your APIs auditable. It creates this immutable, indexed history log on the Ethereum blockchain every single time that owner variable updates. You're not just changing the variable in the dark. You are broadcasting it to the entire network.
Let's actually take a peek at what these scribes are writing down. We're comparing two key moments in our contract's life here. First up, contract deployment. When the contract is born, the previous owner is logged as the 0 address, meaning there was no prior owner and the new owner is the deployer's address. It's the dawn of the kingdom. Then, look at a standard transfer. The event logs the exact handoff. The previous owner is the outgoing ruler and the new owner is the successor. Off-chain indexers read this exact data to build a flawless second-by-second historical timeline of who was in charge.
Now, what's really interesting about this is where it naturally leads us. We've talked about holding the crown and we've talked about passing it. But what if your ultimate goal is true decentralization? What if the protocol is completely finished, the rules are set in stone, and you want no one to be in charge ever again?
That brings us to Section 4, the volcano, renouncing contract ownership.
Welcome to the volcano. This is, without a doubt, the most dramatic mechanism in smart contract ownership, renounce ownership. It's the digital equivalent of hiking up to a bubbling caldera and just hurling the crown straight in. Mechanically, though, it's shockingly simple. Calling it just takes the owner's state variable and sets it to the 0 address. Remember, that's an account nobody has the private keys for. By pointing the owner variable there, we intentionally leave the contract in a permanently ownerless state. The onlyOwner modifier will now block everyone. Yep, even the person who just renounced the ownership, because literally no one's address matches the 0 address. Privileged control is permanently removed.
I really want you to let this quote sink in for a second. Renouncing ownership is irreversible. It removes the ability to perform future administrative fixes. This is a severe one-way street, folks. Now, it's brilliant for trustlessness. If users know the contract has been renounced, they know for sure the developer can't suddenly jack up the fee structure or pause their withdrawals. But it also means if there's a nasty bug discovered tomorrow, there is absolutely zero way to fix it. So it requires incredible deliberation.
Section 5. Testing the flow. Building the transaction demo.
Because these mechanics are so powerful, we really have to verify them locally. At Forge College, we heavily emphasize that you shouldn't just write the code, you must test the entire lifecycle. So here's the chronological sequence of our test script. Step 1, we deploy the contract, which naturally makes our test account the initial owner. Step 2, we execute a valid transfer ownership, moving control to a secondary test account, and we verify that the ownership transferred event actually fires. Step 3, we switch to a completely unaffiliated attacker account and try to steal the crown back. And finally, Step 4, from our new owner account, we call renounceOwnership and throw the crown straight into the volcano.
Testing the failure path is just as vital as testing the success path. Take a look at the expected results here. For that blocked attacker attempt, we don't just make sure the transaction fails. We explicitly verify that the attacker gets slapped with the exact caller is not the owner revert message. We have to prove our royal guard is actually doing their job. And for the final state, after the renounce action, we assert that querying the owner returns exactly the 0 address. We prove, beyond a shadow of a doubt, that the crown is truly gone.
Section 6. Wrap up. The key takeaways.
So the crucial point here is that implementing ownership isn't just about restricting access. It's about managing an entire life cycle. Here are your 3 main technical takeaways. 1. Guard all your state-changing ownership transfers with the onlyOwner modifier. Only the king can crown the next king. 2. Always emit the ownership transferred event to provide an auditable paper trail for off-chain systems. And 3. Treat renounce ownership with extreme caution. It's irreversible and permanently nukes your ability to perform administrative upgrades. Use it very deliberately.
Now that we've mastered how to establish, transfer, and destroy the owner state variable, we've laid a perfect foundation. Next up, in our explainer on applying the onlyOwner modifier, we're going to take these exact ownership checks and attach them to concrete, state-changing administrative functions. We'll start actually locking the doors in our digital kingdom.
Before we go, I want to leave you with this provocative thought. If you throw the crown into the volcano in the name of total decentralization, who fixes the kingdom if a bridge collapses? It's the ultimate trade-off in Web3 engineering between trustlessness and upgradability. Really chew on that as you design your architectures. To dive deeper into this subject, play around with the code from today's demo, and explore more Web3-related topics, make sure to visit forge.college. Thanks so much for joining me on this explainer. Keep building securely, and I'll catch you in the next one.